This presentation is on using the digital trainer. This is the trainer we will use. Let's review the sections we will use in the first labs. There's the breadboard where we'll build the circuits. There's switches. We'll use these switches as our inputs. LEDs. We will use these lights as our outputs. Power supply. This is our voltage source, which we will use to power our circuits. The logic probe. We will use this logic probe to troubleshoot our circuits. Okay, let's look at the breadboard. Let's see how it's connected. Let's split the breadboard into two sections. Holes along the grooves. These things being the grooves, or called the grooves. These holes on either side of the grooves. And the holes not along the grooves. Up to the top, and these sections here. Those are the holes I'm saying are not along the grooves. The holes along the grooves are connected in rows, in groups of 5, like this. If you stick a wire in any one of those holes, it's connected to the other 4. So I'll say here, if a wire is inserted into any one of these 5 holes, it will be connected to anything inserted into the other 4 holes. There are 5 connected together. There are 5 more connected together. The holes not along the grooves are connected in long strips, like this. Those strips are all connected together. If a wire is inserted to one of the holes along the strip, it will be connected to anything inserted to the other holes along the strip. Just like I've shown there, all of those holes marked are connected together. Note that the 2 strips are not connected together. That one is not connected to that one. They are not connected together. Also, note that the strips are not connected across the screws. The top is not connected to the bottom section. If you want them connected together, you have to connect them with a wire. Across the top, the entire strip is connected together. So those sections I'm showing there are all connected together. Okay, the switches. The switches are where we put in our inputs, 0 or 1. There's a little switch there that you can move up and down. Switch 1 is connected to the first 5 holes, like this. So when we move this switch, this is where we connect to it. Any of those 5 holes will work. Switch 2 is connected to the next 5 holes, and so on. The LEDs. The LEDs, or light-emitting diodes, are where we connect our outputs, green for 0 and red for 1. The connections are clearly marked on the trainer. So, if I put a wire, an output, into one of these 5 holes, it's connected to this, and the light will come on red for 1 and green for 0. If I put it into one of these holes, it'll be connected to number 4, and it'll come on red for 1 or green for 0. Make sure this switch is on TTL and not CMOS. Power supply. In this class, we only use the 5 volts and ground terminals. To connect a wire to the terminal, unscrew it, put your wire in the small hole, and screw it back to secure the wire. The switch that turns on the power supply is on the back of the trainer. Logic probe. When you are troubleshooting your circuit, you should use the logic probe For the logic probe to operate properly, you must connect any of the holes marked VCC to 5 volts. There's a lot of holes here. All you have to do is connect one of them to 5 volts for it to work. Make sure the top switch is on pulse and the bottom switch is on TTL. Connect a long wire to any of the holes marked input, any of these. Now you can touch the other end of this wire to any point of your circuit, and the lights at the bottom will indicate whether that point is a 0, a 1, or neither. ICs. In this class, our gates and circuits are on chips, also known as ICs, integrated circuits. There may be a lot of letters and numbers on the chip, but we are most concerned with the chip number. This particular chip is a 7408. The letters between the 74 and the 08 indicate the type of chip. We won't concern ourselves with that right now. Chips should always be placed on the breadboard straddling the groove. Be careful when putting a chip on the breadboard. Make sure the pins are all going into the correct holes and then push firmly on the chip, snapping it into place. Be very careful when removing a chip from the breadboard. This is best done with a chip extractor tool. You can also remove a chip with a mechanical pencil. Do not remove a chip from the board with your fingers. If you do, it is likely that you will bend the pins. Bottom left pin is pin number 1. The rest of the pin numbers continue counterclockwise around the chip, just like it's shown. So if you look at them, if you read the chip, read the numbers, and hold it like this, number 1 will be on the bottom left, over to 7, up to 8, over to 14. It's very important to remember how the pins are numbered on the chips. If it's not a 7 pin, if it was like a 16 pin chip, it would go 1 to 8 and then 9 to 16. All TTL chips can we use require connections to 5 volts and ground in order to operate. Most, but not all, have these connections on the corners. 5 volts is usually on the top left corner. On this chip, it is pin 14. Ground is usually on the bottom right corner. On this chip, it is pin 7. A common mistake is to reverse the corners and connect 5 volts and ground backwards. If you do this, the chip will get very hot and you can burn yourself. It will also probably destroy the chip. Be careful when connecting power and ground to your chips. Building your circuit. Before beginning, you will need a trainer and wire. You might also want to have a chip extractor tool and needle nose pliers. The pliers can be useful when inserting wire into the holes of the breadboard. In EET 201, each student must build their own circuits. You may not work in pairs or groups. This picture shows a chip that is powered up correctly. Notice that 5 volts goes to one of the long strips, and then this orange wire is also in the same strip. It's connected to 5 volts, and it goes to pin 14 of the chip. Ground goes to another long strip, and another wire from that long strip is connected to one of the holes connected to pin 7 of the chip. Yes, I could have gone directly from 5 volts to pin 14 and not used as many wires, but a lot of times I like to connect to the strips. That means this entire strip is now connected to 5 volts. Now, if I had another chip, I could just run its 5 volts to the same strip. Same way with the ground. I could have run the ground directly to pin 7, one of these holes, but instead I've ran it down here, and now I've got this whole strip that is connected to ground. This chip is also powered correctly. Notice that because ground is connected to the strip below the screw, a wire is used to connect the lower strip to the upper one. Here, ground is going down here below the screw, and these holes are not connected to these holes. So in order to make this, it's going down here, connected up to here, I had to put in this little wire to connect the bottom section to the top section. This chip is also powered correctly. Wiring the circuit like this, using short wires, makes troubleshooting easier. You can get to the chip to check. Here, 5 volts goes to a long strip here with a short wire. Then this is jumped over to this long strip, from this top strip to this strip. Now this is all 5 volts. Another jumper connects to the bottom section, so this is 5 volts. And this wire goes to pin 14. So this is actually connected to 5 volts, even with no long wires. Ground is connected here to this one, and it's done similarly. Here, this strip to this strip, across to this strip, and then the short wire to pin 7. Here, switch 1 is connected to the chip. Since the wires were not long enough, 2 wires were used. So going from switch 1 here to the chip, it was a long way. I didn't have a long wire, so I ran from here to this point, just connected to, in the same strip, another wire from that point over to here, in order to get from here to here. Here's a circuit with inputs from switches 1 and 2, and an output on the LED. So switch 1 is jumped over to pin 1. The second switch is jumped over using 3 wires to pin 2. Then pin 3, the output, goes to the LED. I've got my power and ground also connected to the chip, as you must. The output is 0 since the light here is green. So I know that my output is a 0 because my output is lighting up green. Here the output is 1 since the light is red. When you finish your lab work, please take your circuit apart and put your tools, chips, and trainer back into their spots. Your instructor gets very irritated when he has to take apart student circuits.